Hello everyone, this is now the continuation of the reactions in aqueous solutions. So last time we discussed gravimetric analysis, and we have discussed that when you say gravimetric analysis, we are looking for the mass of the reactants using the mass of the precipitate formed in the reaction. Thus, gravimetric analysis is very useful quantitatively for us to identify an unknown solution. So for example, we are given a chemical substance, but we do not know its name or its chemical composition. So we can again use the gravimetric analysis to establish the identity of that unknown substance. So last time we had our computation for this. Now we will be moving on to the acid-base titration. So this is another strategy or technique to identify unknown substances in the laboratory. So we have a lot of that na happenings na we don't know the name or even the composition of the compound. So ito yung mga pwede nating gawin. So when you say titration, we are actually looking for the concentration of our substance. Diba? Sa gravimetric analysis, we are looking for the mass. Again, we are looking for the mass of our reactant or our unknown substance. This time, we will be looking for the concentration. Now, anong ginagawa for titration? We have here a known concentration. Diba? When you look at the chemical equation, we will see most of the time two reactants. One chemical substance reacting with another chemical substance. Now, ang gagawin natin sa titration, meron tayong isang substance there na alam natin yung concentration. So, ang tawag dyan sa reactant na yan is the standard solution. So, again, ang tawag natin sa ating substance na yan is standard solution. Lang, ha? Let me write on the screen. For example, you have this chemical formula, NaOH plus hydrochloric acid yielding sodium chloride, syempre, and water. When we do titration of these two substances here, most likely, pwedeng alam natin kahit isa lang sa kanila yung concentration na yan. So example, si sodium chloride yung known, ito yung known concentration. And then ito naman si hydrochloric acid, unknown, hindi natin alam yung concentration niya. So since ito yung known concentration, ito yung tinatawag natin na standard solution. So i-add natin siya using titration doon sa unknown and ipapag-react natin sila. And then we will also do computations just like in gravimetric analysis to know the concentration of this one. Okay, so that is titration. We have the so-called standard solution. Now, si sodium hydroxide is actually very widely used in the laboratory. However, the problem with sodium hydroxide is it is hygroscopic. So take note of this word, hygroscopic. When you say hygroscopic, ito yung definition niya. It tends to absorb water from air. So, nagli-liquefy siya. Meron tayo actually sodium hydroxide pellets. So parang bilog-bilog siya na parang tablet. Sodium hydroxide yan siya. And then again, if you just let it stand in a table without covering, after some time, nagli-liquefy yan siya. Okay? Nagiging wet siya because nag-a-absorb siya ng water from the air. And aside from absorbing water in the air, the sodium hydroxide solution also reacts with carbon dioxide, which is also present in the air. So for that reason, we don't really use immediately the sodium hydroxide in our laboratory experiments. Instead, before using it, nag-undergo muna ng tinatawag na standardization. So what do you mean by standardization? This is actually determining the concentration, the actual concentration of a substance. So again, si sodium hydroxide, it is very cheap, it is very common. However, the problem is nag-a-absorb siya ng moisture or water from the air. So kung mag-a-absorb siya ng water from the air, most likely nag-iiba ang concentration niya. Diba, we have the so-called dilution also na kapag nag-add tayo ng water or any solvent, nagbabago yung concentration ng ating substance. So ganun din ang mangyayari kay sodium hydroxide. Though hindi tayo deliberately nag-add ng water, but since siya mismo yung mag-a-absorb ng water sa air, nagbabago ang concentration niya. So before natin gamitin si sodium hydroxide in any laboratory experiment, so kahit anong laboratory experiment, before natin siya gamitin, mag-undergo muna ng standardization. And anong ibig sabihin ng standardization? It is determining the actual concentration of our chemical substance. And how do we do standardization? It's through titration. So yun yung ating lesson ngayon, titration. But we will just concentrate first with the acid and base titration. Kasi remember, sodium hydroxide is a base. So most of the time, we titrate it with an acid. So yun yung ginagawa natin for standardization. So before tayo mag-move on how are we going to do the standardization of sodium hydroxide, let's define some terminologies. We have here first the equivalence point. It is the point wherein the acid or the base has been completely neutralized. So meron kang acid. Meron tayong acid here. Let me charge. Okay. Let's continue. Again, we have an acid reacting with a base. Kapag na-neutralize na si acid using the base or na-neutralize na si base using the acid, ang tawag dyan, equivalence point. So, ang nangyayari dyan, there will be equal amount now of acid that reacts with the base. So, equal na yung kanilang concentration. Again, ang tawag dyan, equivalence point. But equivalence point is a theoretical value or a theoretical point. We cannot really see it with our own naked eyes. So ano lang siya, parang approximation. Ang nakikita natin during the titration process is actually the so-called endpoint. Ito yung nakikita natin. This is endpoint here. So ito yung nakikita natin during titration wherein there is a change in the color of the solution. And kapag nag-change na ang color ng solution, that will now give us a hint na we have to stop the titration process. Okay? Kasi yung endpoint is actually near the equivalence point. And the reason why nag-change ng color yung ating solution, it's because of the presence of the indicators. So si indicator class, ano siya? Ibang chemical substance na naman siya na ina-add natin doon sa ating solution. And ang trabaho niya is nag-change siya ng color kapag there is a change in the pH of the solution. So kung kapag nagiging acidic na, nag-change siya ng color, or kung nagiging basic na ang solution, nag-change din siya ng color. So kasi, again, we cannot really see the equivalence point. It's just that an approximation na equal na amount ng acid ang nag-react with the amount of the base. So endpoint talaga yung nakikita natin in the titration process. Now, one type of acid that can be used in the standardization of sodium hydroxide is potassium hydrogen phthalate, or we abbreviate it as KHP. Now, this one is a monoprotic acid which is often used in titration. Monoprotic means isang hydrogen lang yung kaya niyang i-give up or maa-ionize during the chemical reaction. Now, the molecular formula of potassium acid phthalate is KHC8H4O4, which has a molar mass of 204.2 grams per mole. Chemically, it is described as a white soluble solid that is commercially available in highly pure form. So meron tayong available na pure potassium hydrogen phthalate talaga na pwedeng gamitin for the titration process. Now, if you use potassium hydrogen phthalate in the titration with sodium hydroxide, you can see in the screen the chemical reaction. So KHC8H4O4 in aqueous solution will react with sodium hydroxide, yielding potassium sodium phthalate and water. So yung net ionic equation nasa baba, parehas lang actually yan. You have there the phthalate ion reacting with the hydroxide ion from the sodium hydroxide, and mag-yield siya ng phthalate ion and water also. So it is class a neutralization reaction here. KHC8H4O4 is the acid, and then sodium hydroxide is the base. Now, in the laboratory, we use the following procedure for the titration. So actually, though the example here is the reaction between potassium hydrogen phthalate and sodium hydroxide, you can actually use this procedure to some other acids and bases if we want to titrate them and know their concentration. So again, in the laboratory, ang ginagawa natin first is aalamin natin yung amount ng potassium hydrogen phthalate na gagamitin natin in the reaction. Actually, tayo yung mag-measure nito. Potassium hydrogen phthalate is in the form of powder. So magme-measure tayo ng mass na gagamitin. Ita-transfer natin siya sa Erlenmeyer flask if alam na natin yung amount niya. And then dadagdagan natin ng distilled water para makakagawa tayo ng potassium hydrogen phthalate solution. Now, after that, the sodium hydroxide solution is carefully added to the potassium hydrogen phthalate solution, and we will do that using a burette. So, in the titration process, if this is the burette class, I hope you can still remember ano yung mukha ng burette natin. Dito natin ilalagay sa burette si sodium hydroxide, and nasa Erlenmeyer flask naman si KHP or potassium hydrogen phthalate. So idadagdag natin dyan si sodium hydroxide until we reach the equivalence point. So a while ago, I discussed what equivalence point is. It's the point wherein all the potassium hydrogen phthalate in our solution has been neutralized by the sodium hydroxide. However, sabi ko kanina, we cannot really see the equivalence point since this is just theoretical. So, approximation lang talaga siya. Ang tinitingnan natin to end the titration is the endpoint wherein there will be a change in the color of the solution here in the Erlenmeyer flask. So, ang ginagawa, hihintayin, mag-a-add pa more ng sodium hydroxide solution until mag-turn ang solution into pink. And that will signal that the solution has become basic due to the addition of the sodium hydroxide. Yun yung ginagawa natin in the laboratory. In the folder sa Schoology, I will include a link na pwede niyong tingnan sa actual talaga ng procedure ng titration for the sodium hydroxide standardization using the potassium hydrogen phthalate. So please watch it para ma-visualize natin kung ano yung ginagawa in the titration. Mahirap kasi siyang intindihin kapag ganito lang, words lang lahat. Pero makikita nyo sa video at the end of the titration process, after adding the sodium hydroxide, you will see that the Erlenmeyer flask will really change from colorless to faint pink or a pale pink na color that signifies the end point of the titration. So, nasabi ko rin kanina na the one responsible in the change sa color is the phenolphthalein, or I mean the indicator, but to be exact here in the titration, most of the time, we use phenolphthalein for sodium hydroxide and KHP. So itong phenolphthalein, ina-add siya doon sa Erlenmeyer flask na merong potassium hydrogen phthalate. Most likely mga 2 to 3 drops, and since acidic si KHP, the original or the initial solution will be colorless. But if we add now the sodium hydroxide, magiging reddish pink siya. And that is the color of phenolphthalein in the basic solution. Because remember, diba, sodium hydroxide is basic. So ito yung setup natin for the titration. You have there the iron stand. This one is called the burette clamp. So in your activity 1 sa laboratory, kasama si burette clamp no sa list of apparatus natin, ginagamit siya to hold the burette, especially for titration. So in the burette, again, you will place here the sodium hydroxide. Again, you will place here the sodium hydroxide solution. And in the Erlenmeyer flask, this is where you place the potassium hydrogen phthalate plus the indicator, which is phenolphthalein. So phenolphthalein is one example of an indicator. Marami tayo actually indicator. Pwede din nating gamitin. So i-add yan siya hanggang mag-turn ng ganitong color yung solution sa Erlenmeyer flask. And we call it now the endpoint, meaning isa-stop na natin yung pag-add natin ng sodium hydroxide. So phenolphthalein is again color pink or reddish pink kapag ka nagiging basic na yung solution natin. And tinatawag nating equivalence point yung theoretically approximation natin na na-neutralize na lahat ng potassium hydrogen phthalate in the solution. Pero hindi kasi natin siya makita. Kaya nag-a-add tayo nitong phenolphthalein. Okay? Now, we have here a sample problem kasi when we do titration, most likely we are looking for the concentration of one of our reactants. And most likely it will be the sodium hydroxide. Kagaya ng sinabi ko kanina, si sodium hydroxide is very hygroscopic, so it tends to absorb moisture sa air, kaya nagbabago yung kanyang concentration. So we have here, in a titration experiment, a student finds that 23.48 ml of a sodium hydroxide solution are needed to neutralize 0.5468 grams of potassium hydrogen phthalate. Take note of the question. What is the concentration in molarity of the sodium hydroxide solution? So hindi natin alam, class, ang concentration ni sodium hydroxide solution, specifically in molarity. Pero nag-titrate tayo, nagawa tayo ng experiment. And during the experiment, we have the following data. So yung mga given natin, the amount of KHP na ginamit in the titration is 0.5468 grams. And the amount of sodium hydroxide na na-add doon sa solution before siya nag-change ng color is 23.48 ml. So hahanapin natin ngayon ang molarity. Okay? So, how do we compute this? For the strategy, actually, we will still use the same formula for molarity. Hindi naman yan nagbabago. It's still molarity. Molarity is equal to moles over liter of solution. So, specific lang yung nakikita niyo sa screen kasi we are looking for the sodium hydroxide. Okay? So, let's continue. So, paano nga natin ginagawa? We are looking for the molarity. So, anong ginagawa natin, diba? Yung weight in grams is always given. Tapos, i-convert, hahanapin natin si moles before we can get the molarity. So, in this case, kapag ka-titration kasi ang ginagawa, class, nagiging equal yung amount ni potassium hydrogen phthalate and ni NaOH. So again, magiging equivalent sila. Kaya kahit na ang hinahanap natin is ang molarity ni sodium hydroxide, we can still use the amount of potassium hydrogen phthalate. So we will get first the mole. This is equal to the weight in grams divided by the molecular weight. Pero remember that the weight in grams na binigay is for the KHP. So, ang hahanapan mo rin ng molecular weight is si KHP pa rin. So, ang given, 0.5468 grams divided by the molecular weight. I think binigay ko siya kanina. It's 204.2 grams per mole. Let's cancel the grams. We will get here 0.5468 divided by 204.2 is 2.677766895 times 10 raised to the power of negative 3 moles. So, na-shortcut lang yung dito sa ating example. Now, if we have computed for the moles, then we can proceed with the molarity. So, molarity again is equal to moles per liter. So, yung moles na hanap na natin, 2.6777666895 times 10 raised to the power of negative 3 moles divided by the liter of solution. And for titration, the liter of solution is the amount of sodium hydroxide that was used. So in this case, yung nagamit, diba, is 23.48 ml. Iko-convert lang natin siya sa isang liter, meron tayong 1,000 ml. So 23.48 divided by 1,000 is 0.02348 liters. So ito yung gagamitin natin in the computation. Okay? So 2.6777666895 times 10 raised to the power of negative 3 divided by 0.02348 kung 4 decimal places. you just follow my instruction. If ever mag-quiz tayo or mag-exam tayo, you just follow kung ano ang nakalagay sa instruction ko, kung 2 decimal places ba or 4 decimal places. Kasi yung ginamit sa example is 4 decimal places. Pag sinabi kong 2 decimal places lang, so ang answer natin dito is 0.11 moles per liter or simply capital letter M. So ayan, alam na natin ngayon yung concentration ng ating sodium hydroxide solution. Okay, that's how we do it using the acid-base titration. Hindi natin alam yung concentration ng ating solution. Before we move on to redox reaction, let me give you another example. Okay, so this is another example for the computation in the acid and base titration or neutralization reaction. We have here compute for the molarity of sodium hydroxide solution if 0.95 grams of potassium acid phthalate was used to titrate 30 ml of the sodium hydroxide solution. By the way, potassium acid phthalate is the same with potassium hydrogen phthalate. Parehas lang yan sila. Okay, so let us start with our computation. Let's have first one. Syempre, we will list down the given. So in the problem, let's take note that the KHP used was 0.95 grams and the sodium hydroxide solution used was 30 ml. Now we are looking here for the molarity. So what was again our process? Since the weight in grams is given, then we will be computing for the number of moles, and then after that we can proceed in the computation of molarity. So in computing for the number of moles, syempre we will use this formula. Moles is equal to the weight in grams divided by the molecular weight. So the weight in grams is for the potassium acid phthalate. Therefore, we will also use its molecular weight. Though we are looking for the molarity of the sodium hydroxide. So do not forget in titration, if you have reached the equivalence point, there will be equal amount of the potassium hydrogen phthalate that will react with the NaOH. So mag-i-equal yung kanilang number of moles. Kaya pwede natin gamitin yung weight in grams and molecular weight ni KHP in the computation. So again, the given is 0.95 grams divided by the molecular weight a while ago, that's 204.2. Just memorize this na lang para hindi kayo pabalik-balik mag-compute ng molecular weight ni KHP. So let us cancel the grams. Our number of moles here is, let us solve. This is 4.65 230.1665 times 10 raised to the power of -3 moles. Now what's next? After computing for the moles, then we can proceed with the computation of the molarity. So molarity now will always be moles divided by liter of solution. So the computed moles is 4.65230.1665 times 10 raised to the power of -3 moles divided by, for the liters of solution, we will just convert. So again, we will just convert. What was the given again? 30 ml. So 30 ml times ml sa baba, liter sa taas, so that we can cancel. 1 liter is equivalent to 1,000 ml. So 30 divided by 1,000 is 0.03 liters. Okay, so that's what are we going to use in the computation, 0.03 liters. So let's solve for the molarity. 4.652301665 times 10 raised to the power of negative 3 divided by 0.03. The answer is kung 2 decimal places, it will be, let me just write the whole answer first. And then we will round off later to 2 decimal places. So 0.15507672 moles per liter, or we can simplify this to decimal places, 0.16 molar. Okay, so now even if in the start we don't know the concentration of sodium hydroxide, we just know na ito yung pwede natin gawin, mag-titration tayo, and then we use potassium hydrogen phthalate with a specific amount, 0.95 grams. And then pag-titrate natin, 30 ml yung naggamit natin na sodium hydroxide. Afterwards, we can always compute for the concentration in molarity. So this is now the concentration of the unknown, and that is the sodium hydroxide solution. Okay? I hope naintindihan yan. So again, please watch the videos, the links for the sample procedure and how to do the titration para meron kayong knowledge paano siya ginagawa sa laboratory. Now, aside class from the acid and base titration, we actually always do also do redox titrations. So, di ba, pag sinabing redox reaction, you have the reduction, the oxidation, they always involve transfer of electrons. Pero, kung kapag sa process is we don't know the concentration of the reducing agent or the oxidizing agent, pwede din natin gawin yung titration, kagaya ng sa acid and base titration. So kung sa acid and base titration, nagpapareact tayo ng acid and base para malaman yung concentration ng either acid or base, dito naman itatitrate natin si oxidizing agent against a reducing agent, and take note that the procedure is similar. Okay? So, pwede nating gawin yon. Oxidizing agent and then reducing agent. And just like sa acid-base titration, we have the so-called equivalence point wherein there will be equal amount of the oxidizing agent na magre-react with the reducing agent. Pero pagdating sa endpoint, paano natin makikita yung signal na end na yung titration? It's through color change pa rin. Okay? Magko-color change pa rin siya. So this will be the last lesson, the redox reaction or redox titration. So when you say redox titration, this normally require an indicator that clearly changes color. So kagaya ng sa acid and base titration. So merong mga titration process sa redox na nagre-require ng indicator. Meron din namang hindi nagre-require ng indicator because some of the oxidizing agents can be the indicator themselves during the titration. Nag-iiba kasi yung color nila when they are oxidized or reduced. Depende kung anong nangyari sa kanila. So mag-a-assume sila ng color during the reaction. So, if ever mag-change na ng color during the titration, stop na yon, endpoint na yon siya. And that we can now approximate or estimate the equivalence point. Now, we have two common oxidizing agents that we use in the laboratory. For example, meron tayong reducing agent, tapos hindi natin alam ano yung concentration nila. So we can titrate them either with potassium permanganate or the potassium dichromate. So, hindi sila mga colorless solution. Potassium permanganate is color violet and potassium dichromate is color orange. Now, when we titrate them with a reducing agent, nagpapalit sila ng color class. Okay? Nagpapalit sila ng color. So, si potassium permanganate na color violet or purple, pagkatapos ng titration with a reducing agent, magiging light pink na siya. While si potassium dichromate from orange or orange yellow, magiging green na siya. So it's because they are either oxidized or reduced. Okay? So in this case, si oxidizing agent will actually be reduced from permanganate, magiging manganese ion siya. Pag na-reduce siya, mag-iiba siya ng color. So kapag ganito yung oxidizing agent na gamit during titration, hindi na kailangan ng additional na indicator. Sila mismo ay magiging indicator na during the titration. So yan lang yung sa redox reaction. Dapat alam niyo lang na it's between an oxidizing agent and a reducing agent. Pag acid-base titration, it's between an acid and a base. The procedure is similar and the computation actually for the molarity is also similar. Okay? So, again, I will be sending links also for the procedure sa ginagawa natin sa laboratory for this.